In this video, let us understand about coefficient of variation. So here is an example, runs scored by batsman A at the batsman B. If you find the average runs scored by batsman A as well as the runs scored by batsman B, both averages will be equal to 40. But if you want to find who is more consistent in their performance, then we have to use the concept of coefficient of variation. Standard deviation is the absolute measure of dispersion, whereas the coefficient of variation is the relative measures of dispersion. The data set for which the coefficient of variation is greater is said to be more variable or less consistent or less uniform or less stable. For the data set for which the coefficient of variation is less is said to be less variable or more consistent or more uniform. How do we measure the coefficient of variation? We measure the coefficient of variation by using the formula. Coefficient of variation is equal to standard deviation divided by the average multiplied with the 100. Let us consider an example. Here, price of a particular commodity in 5 years in 2 cities are given. We want to find in which city the price is higher and in which city the price are more stable. So, this is the data set given to us. So, in order to answer this question, we shall find coefficient of variation for both the price given in city A and city B. So in order to find that, let us construct a table price in city A, similarly a price in city B involving the data X, and then let us find X square for that. Here X is the price given in city A, that is listed here, and X square is the square of the particular data. So as we know, 20 square is 400, 22 square is 484, like that. Let us find the square of each data listed in the price in city A. So similarly, let us consider price in city B, and then for each data let us find X square and let us find the total of all these values. So after that, let us use the formula. Coefficient of variation is given by standard deviation divided by X bar, that's the average, multiplied with the 100. So let us find out individually average price in city A by the formula. X bar is total of X divided by N. So here total of X is 100 and N is we have considered 5 years data. Therefore here N will be equal to 5, and then we come to know that the price in city A, the average price in city A is 20 rupees. So similarly, let us find the standard deviation in the price by using the formula listed here, and then if you substitute all the values, we get 2.45 as the standard deviation in the price. Then coefficient of variation, substitute all these values. So standard deviation is 2.45 and the average is 20, multiplied with the 100, we get 12.25. So similarly, calculate the average price in city B, standard deviation in the price in the city B. Similarly, the coefficient of variation in the for the prices in the city B. So we see that arithmetic mean for city A. So arithmetic mean for city A, which is 20, and it is more than the arithmetic mean for the price in city B. Therefore, we can say that the price in city E. So therefore, we can say that. So here the question is, in which city the prices is higher? So therefore, we can see that the price in the city A is higher compared to the city B. And we also want to answer the question, in which city the price is more stable. In order to answer this question, we shall look at the coefficient of variation value. Coefficient of variation for city A, it is 12.25, and the coefficient of variation For city B, it is 24.6. So we observe that coefficient of variation value for the city A is lesser than the city B. So therefore, we say that the price in city A are more stable compared to the city B. So here I have got another example, and this is a discrete data. So here we have got goals scored by two teams A and B in a football season as follows. We want to find which team is better and which team is more consistent. So since this is a discrete data, so let us construct a table. So number of goals, let us consider it as X, and the team A, the frequency, that's the number of matches they played, that is taken as frequency. So here we see that among the 27 matches, they scored 0 runs, and among the matches they played, in 9 matches they have scored 1 run, so 1 goal. Like this the data is listed. Similarly, the data is listed for city B, and then let us find the corresponding value of x square, then f into x square, similarly f into x for team A as well as team B, and let us sum all the values, and then we shall find the average for city team A as well as the team B, and also we shall find the standard deviation by using this formula. So this if you compute the values, we find that the average goals scored by team A is 1.06, and the average goals scored by team B is 1.2, and the standard deviation in the goals scored by team A is 1.306, and the standard deviation in the goals scored by team B is 1.307. So then let us find coefficient of variation by using the formula standard deviation divided by the average multiplied with 100. So we get the coefficient of variation values for the team A is 123.20%, and for team B is 109%. So we see that team B, the team B value, team B is having the coefficient of variation lesser compared to the team A. So hence we say that team B is more consistent in scoring the goals compared to team A. So now I'm considering here one more example which is based on the continuous observation. So we have got lives of two models of the refrigerator A and B, and then we want to find which model has a longer life and which has more uniformity. So similarly, let us construct a table. So life in number of years is given to us, and then here x is the mid value of each class. So here 0 to 2 the mid value is 1, 2 to 4 the mid value is 3, 4 to 6 class the mid value is 5. So like that the mid value is listed here, and frequency is the life in years for the refrigerator given for the A model. So similarly we have listed the life in years for the refrigerator B model, and then we have computed all these values which will be required to find the average as well as to find the standard deviation. So then let us find the average by using the formula f into x divided by n. So we get the average lifespan of the refrigerator A as 5.12 years, and the average lifespan of the refrigerator B as 6.16 years. So similarly, calculating the standard deviation by this formula, we get 2.99 years as the standard deviation for the refrigerator model A, and 2.23 is the standard year 2.23 years of the standard deviation for the refrigerator B. Then compute the coefficient of variation by using the formula standard deviation divided by x bar multiplied with 100. So we get the coefficient of variation as 58.39% for the refrigerator A, and coefficient of variation for the refrigerator B is